Okay, so I want to talk to you guys about the review that you did the other day. I'm going to give you guys a question at the end that you can calculate to input a passcode or an exit ticket at the end of this. This is going to be for today's lesson. So let's start with some of the questions early on here. Now, I know we didn't necessarily have specific notes on these, but I think we all know what, and you're going to see a bunch of these questions. You're going to have atmospheric pressure, intrapulmonary pressure, and intrapleural pressure. Your atmospheric pressure, that's going to be the air outside the body. That's the air that's around us. And we know that when we breathe and how we breathe, we have to be able to change the internal pressure of our lungs. So if we can change the pressure inside of our lungs, we can get air to move in and to move out. We are not changing atmospheric pressure over short periods of time. That we can't change it at all, and it doesn't change drastically in a short period of time. So atmospheric pressure is going to remain constant. What we can change is intrapulmonary pressure, okay? And intrapleural pressure is also going to remain constant. But by our breathing mechanisms, our moving our diaphragm and moving our rib cage, or using our external intercostals to pull the ribs out, internal to pull them back in, and the diaphragm going back to a relaxed state, we can change the shape and the size, which then in turn changes the pressure of our lungs. That's going to be your intrapulmonary. If you remember our root words, intra means within or inside. Pulmonary means lungs. So intrapulmonary is going to be that pressure inside your lungs. The intrapleural pressure, pleural is the space around the lungs. You've got two layers outside the lungs called the pleural membrane, which reduces friction when you breathe between the lungs and the heart. And the intrapleural pressure is going to remain constant. And if you remember from the video that we saw in the notes from last week, you'll remember that when that individual had the puncture wound from the bullet going through the chest, the intrapleural pressure was compromised, which forced the lungs to collapse. So, looking at the first question there, it says in healthy lungs, it's always lower than atmospheric pressure. And that's going to be, and you can see the correct answers are all labeled here. I know you guys have these as well. That's going to be your intrapleural pressure. If it was higher, then that would cause a problem in which the lungs may collapse. Pressure of air outside the body, that's just going to be your atmospheric pressure. The third one here says as it decreases, air flows into the passageways of the lungs. Okay, so that one's going to be our intrapulmonary pressure, because as the pressure in the lungs drops, that means the atmospheric pressure is now higher and air is going to flow in. The next one is as it increases over atmospheric pressure, air flows out of the lungs. Again, we can change the intrapulmonary by pulling the rib cage back in, diaphragm going to a relaxed state. That increases the pressure by reducing the size of the thoracic cavity, and that's going to force the air back out. So that's going to be an expiration. It says if this pressure becomes equal to atmospheric pressure, the lungs collapse. That's going to be your intrapleural. That's the space around the lungs. And then the last one rises well over atmospheric pressure during a forceful cough. Again, that's going to be pressure inside the lungs, and hopefully that makes sense, and you'll see that come up later as well. For this image here, let's talk about what's going on here. And you can see that along the top, it says internal volume of the thorax. That's going to be your chest. Internal pressure in the thorax, size of lungs, and direction of airflow. What you were to do is just put an X all the way across in the spaces of, what does it go up? Does it go down? Air going in or out of the lungs. So for the first one, it says internal volume of the thorax. Well, when the diaphragm, and you can see it says activity of diaphragm, when the diaphragm contracts and moves down, it's going to a more flat position. It's going to increase the size of the thorax. That's going to increase volume. So we would put an X right next to that where the arrow is pointing up. For relaxed, when the diaphragm is relaxed, you're going to do the opposite. You're going to put an X where the arrow is pointing down. For internal pressure in the thorax, okay, when the volume goes up, the pressure goes down. So we put an X under the down arrow. When the volume goes down, the pressure goes up, and that's going to be with the diaphragm in the relaxed position. We'll put an X there. Actually, I'm going to screenshot this and let's go ahead and add that to Notability as well. Yep, we're going to add it to this. All right, let's go back here. All right, let's go into Notability now so I can draw on this. That way, this will be a little bit better here for us. So we're going to increase this. All right, so here's what we're talking about. We've got activity of the diaphragm. What's going to happen to the diaphragm? Well, when the diaphragm again contracts and moves downward, when the diaphragm moves down, that's going to increase the volume of the thorax, so increase the space there. When it's relaxed and goes back superiorly, that's where we're going to put our X there. Internal volume decreases. Okay? Well, when the volume decreases, the pressure is going to increase. So where it says activity of the diaphragm contracts, and the diaphragm is flattening out, the pressure is going to be reduced. Okay? When the diaphragm is relaxed and moves superiorly, the pressure is going to increase. Size of lungs, that's going to change. The size of the lungs and the volume of the thorax are going to be the same. So when the diaphragm contracts and the volume of the thorax increases, lungs will increase as well, and then just the opposite for when it's relaxed. Airflow. When the diaphragm contracts, air is going to flow into the lungs because the pressure is decreased. When the pressure is lower than atmospheric pressure, air is going to go in. When it's relaxed, air is going to go out because the pressure increases over atmospheric, and the air is then going to flow out. Okay? So let's take a look at this guy here. For this one, this is one that probably confused a lot of people because we hadn't talked about it. This area right here in the center, labeled B, those are your normal tidal volume breaths. Okay, so those are going to range anywhere from 200 to 500 milliliters. Air flowing in and out. Okay, you can see all these little tidal volumes, just these normal breaths. Now, as air is coming in, if we want to go, let me erase this here. Let me erase all this. So we've got air coming in, air going out, air coming in, and then you notice this huge peak here. That is going to be your inspiratory reserve volume. That's the air that you can take in over top of a normal tidal breath. So that's going to be IRV. Then you see we come back, we exhale, and then we take a big exhale. So we took a full inhale, we took a full complete exhale, we come back, and now we're breathing normal again. Big inhale, full exhale, normal breaths, inhale, exhale, and you get the idea here. So let's go back and we're going to erase all this again. we've got tidal volume here. We've got IRV, which is this. And actually, let's do this. It's going to be tidal volume. Let's change the color. That's going to be your IRV. Let's change it again. This here is going to be your ERV. That's your expiratory reserve. Keep these. These are going to be tidal breaths. Inspiratory. Normal. Expiratory. Back to normal. Expiratory again. We're just going to finish this out. Tidal volume, inspiratory reserve, our tidal exhale, our expiratory reserve, and back to our normal tidal breaths. Okay, so that's what's going on in all of those questions that deal with, you know, what is showing A, what is B, what is C. E is going to be everything together, full inhale, full exhale. That is going to be your vital capacity. Okay, that is a tidal volume plus an IRV plus an ERV all together, giving you your your vital capacity. Okay, so let's go back to our questions. That's going to answer, you guys can go through these, and I think these guys will make sense to you. What we're looking at is the difference between inspiration, expiration, internal respiration, external respiration, and then ventilation is just simply exchange of air. So review those definitions. Those are just basic matchings. This one with the hiccups, yawns, cough, sneeze, crying, laughing. I think what will help you memorize this, if it's an upper respiratory clearing, it's a sneeze. That's coming out your nose and mouth. A lower respiratory is going to be a cough. So the deeper ones are coughs. The upper respiratories are sneezes. Hiccups in the first one there, you can see that's a spasm of the diaphragm. If the diaphragm suddenly moves up quickly, it's going to force air out quickly, and that's what a hiccup is. Yawn, they don't really know exactly why we yawn. Sometimes if you go to Mythbusters, we'll talk about yawns and whether or not yawns are contagious. Maybe we'll check one of those out this week. It is kind of funny and interesting to watch them try to experiment on people and see if yawns are contagious. But it is not believed to be because of a need for an increase in oxygen, but that is what some people think. And then crying and laughing, I think when you read that definition, it'll make sense to you. Here's your definitions. The one that's not from that, what we just went over, you're not going to see dead space volume on there, and you're not going to see residual volume in that chart that I just showed you. So you may need to review those, the other ones we just talked about. All right, so I'm going to come back to those. You can see this is where you're going to see the questions related to what we just talked about, okay, on all these volumes. So hopefully go back, reread that, or listen to it, and that should help you with those. So let's go to all these ones that don't belong. Let's pick one that doesn't belong. I do give descriptions of those and why they don't belong. Let's talk a little bit about what some of these terms mean, though. Acidosis means that obviously the blood is becoming more acidic. Carbonic acid is formed from the combination of carbon dioxide and water. So if you add CO2 to the blood, it becomes more acidic because it's forming carbonic acid. That's going to cause the pH to drop. A drop in pH means more acidic. Anything below 7 is acidic, anything above 7 is basic. So if we move up on the pH scale to bigger numbers, that means it's become more alkaline. If it's dropping in numbers, then that means it's becoming more acidic. Okay, so pH raising doesn't belong here because carbonic acid means that the pH is actually dropping, which is acidosis. For the next one here, we got respiratory rate increases, CO2 in blood decreases, alkalosis and acidosis. Well, both of those can't be right on the last two. Acidosis is the one that's not going to belong there because when you increase your respiratory rate, you're getting rid of more CO2. By getting rid of more CO2, it becomes less acidic, more alkaline. So all three of those go together. Acidosis doesn't belong. Acidosis, hyperventilation, hypoventilation, and CO2 buildup. In this one, hyperventilation doesn't work because hypoventilation, HYPO, that is slowing your breathing rate. If you're slowing the breathing rate, you're not getting rid of as much carbon dioxide, which means it's going to build up, which is going to become more acidic. Therefore, acidosis, hypo, and CO2 buildup all belong together. Another one here, the last one, picking the one that doesn't belong, apnea. PNEA, if you remember, our root words means to breathe. If you put an A in front of it, that means not. So apnea is not breathing. Cyanosis, cyano is blue. That's when your skin is turning blue from lack of oxygen. So that one's going to go with oxygen lowers. As the oxygen lowers, you become more blue. Your skin's going to turn more blue, your nail beds, your lips. And that could be caused by, well, will be caused definitely by apnea, not breathing. So the most famous of the apneas, sleep apnea, is the one that you hear most about, and that can be really dangerous if you're not breathing in your sleep. Again, you can review all those. All the answers are there, and we just went over those. So hopefully that helps you a little bit. We are having a test on Tuesday, and you can go back in, review your structures, review this, and your exit ticket for viewing this and reviewing all these. I would highly encourage you to go back in and do the quiz again, but your exit ticket is going to be to calculate. Let's go back. Let's go here. You're going to calculate vital capacity. Okay? And I'm going to tell you that your tidal volume is 500. Your inspiratory reserve, let's say, is let's say your inspiratory reserve is 2,000. These are going to be milliliters. And your expiratory reserve is going to be 1,100. So your job is to calculate your vital capacity given those three values. And go ahead and put that into your exit ticket for the assignment. I'll create an assignment for that and just put in the text entry what your answer would be in milliliters. Okay, hopefully everyone's doing well. If you have questions, feel free to contact me and I can talk you through some of that stuff.